Hi, my name is Jesslyn, and I'm the marketing manager here at Newtonian. Today, I'll be walking you through the process of using Eureqa to predict the next trading price of a bond. This data is provided through Kaggle.com. So, let's get started. Just for a bit of background, Kaggle is a community of data scientists that have experience in a wide array of industries. Companies host competitions with real-world data sets and problems, and the community competes to provide the best solutions. The majority of the data is available for download even if you do not plan to compete. So Kaggle is a terrific resource for people to test machine learning techniques on real-world data. Now the goal of this specific competition is to find an algorithm that predicts the next price that a corporate bond will trade at. The data here is provided from a company called Benchmark Solutions, and they provide information such as current coupon, time to maturity, a reference price, and more for a number of bonds. We will be using this data to demonstrate how Eureqa uses the power of symbolic regression to easily generate a solution. We won't go too in-depth with all the features that Eureqa provides, but you'll still be amazed at the accuracy of the model we are able to generate. Let's take a look at the data. If you go to the data link in left-hand navigation, you will see what data files provided with this competition. I've already taken a look, but you can download and take a look at the trading dataset, the test dataset, a benchmark, an example submission, and old data. All we need for this walkthrough is a trading dataset, which you can go on to download in whatever format is easiest for you. This is a simple dataset for us to work with, since a trading dataset only involves one table. Datasets that use multiple tables require much more pre-processing work to put into a format that's easy for Eureqa to digest. We can still work with those more complicated datasets, but this is a fairly easy example for us to walk through. Let's take a first look at this data before we move to Eureqa. We can see that there are 61 columns, each signifying a different parameter. So it goes all the way over to this BI column. Now, the parameter that we are most interested in is a trade price column. This is what we want to predict given the values of the other parameters. However, you'll also see that there are over 750,000 rows of data in this file. For ease of use, let's cut it down to about 200,000 rows before continuing. You could extract the 200,000 rows manually, but I recommend using a computer terminal and running a one-line command to downsample the file. We looked at this file in Excel, but let's check it again in the terminal quickly. If I use the command wc-l, I can see the row count of this particular file. So here, again, we see that there are over 750,000 rows in this file. Now, let's run the command to downsample the file. This command is head-n 200,000, the name of the original file, and the name you want the new file to have. Now that we've run the command, let's check the row count of the file we've just created. And ta-da! Just like that, our new data only has 200,000 rows. Now that we have a simple data set to work with, let's go ahead and import the data into Eureqa. When you first open Eureqa, you'll notice that there are 7 tabs running across the top of the program and a navigation section on the left-hand side. These tabs on the top will guide you through the steps to run your own searches in Eureqa, and we'll be walking through each of them in just a moment. So, now that you have Eureqa open, go to the File menu, select Import Data, and choose your data file. Once you've selected it, you may notice a bit of a lag in importing your data. Even though we've downsampled the dataset to 200,000 rows, that's still quite a lot of data. It should only take a few seconds though, and then you'll be ready to rock and roll. Let's just take a quick look here to confirm that all the data was imported correctly. You'll notice that I filled out the descriptive row to describe each column of data. You won't have this in the data you just imported, but feel free to add this in the description if you find it helpful. Scrolling to the right, everything looks good. Goes all the way over to the column BI. Perfect. And scrolling to the bottom, let's go all the way down. We have exactly 200,000 rows, so perfect. This looks like everything imported properly. Now we're ready to move on to the next tab. So in the Prepare Data tab, Eureqa gives us the option to do some data pre-processing before we run any searches against the data. For example, you can smooth the data, handle any missing values, remove outliers, and more. For this walkthrough, we're going to work with the raw data directly instead of going through any of these options. You can go back later to ask Eureqa to automatically handle missing values or any of those other options, but let's just keep moving on for now. In the Set Target tab, this is where we tell Eureqa what value we're trying to solve for, which other variables could be potentially useful in creating a model, and what types of math forms we'd like Eureqa to consider, as well as a few other options. First, let's focus on the target expression area. As we saw when we first opened up the data in Excel, the trade price parameter is what we want to solve for, so that's our target. Every other parameter goes into the right-hand side of the equation, with two exceptions. The first two columns in our data, if you remember, were actually row ID and bond ID. These are helpful in time series analysis, but our objective right now is just to do a quick first pass of the data. So we won't include them in the right-hand side. Using this equation, this is how we tell Eureqa what to search for and how to search for it. Next, let's take a look at the building blocks. We use these to tell Eureqa what kinds of mathematical building blocks it can use to create models. Just as a general best practice, we tend to choose fewer building blocks to start off with, then bring in additional complexity to subsequent models. Using fewer building blocks in the beginning speeds up the search process, so we can get to some kind of initial finding quickly. In this case, we're going to leave the basic building blocks checked, so these 7, uncheck the 2 trigonometry building blocks that were automatically checked, and ignore the rest for now. There are quite a few other options in here though that you can return to if you have time, and you can check out the link on the right hand side to learn more. But this should be good enough for now. So that's it for this tab. There's still many more options we can play with, such as changing the error metric or setting row weights, but those options aren't necessary for this data set. You can come back to these later to refine your search, but we won't go into that in this walkthrough. Now that we have everything set up in Eureqa, we're ready to start searching for solutions. Click the Run button near the top of the tab, and Eureqa will begin using symbolic regression to find the best possible fits for your data. If you run the search on your own local computer, Eureqa will use the cores available to you, typically 2 or 4, maybe 8. However, you can add additional cores using 2 different methods. Either you can use your own dedicated private cloud or leverage the cloud using Amazon EC2. To set up your own private cloud, you will need to download our Eureqa server product and install it on a server that you own. Connecting to the server will allow you to leverage your internal server's computational resources. Alternatively, Amazon EC2 gives you access to up to 200 cores on demand for your specific search. Okay, I've gone ahead and run the data already. So this is what the Start Search tab looks like once you start seeing results. In my case, I used 72 cloud cores for the search, so I was able to achieve results much more quickly than if I had only used my local computer. On the left-hand side of the tab, we can see various statistics about the overall performance of the search. From the top, you'll see that the search ran for about 20 minutes, went through nearly 250,000 generations within those 20 minutes. Next, the confidence metrics represent how close the search is to its end state. Maturity measures how long ago the top solutions last improved, while stability measures how long ago any solution improved. Once both of them reach 100% or close to 100%, you'll know that you've pretty much reached the end of the line with them, and you won't see any more significant gains from continuing to run the search. In this example here, maturity only measures at about 68%, so it still has a bit of a ways to go before plateauing. On the right-hand side of the tab, we see a progress plot. This charts the highest accuracy yet achieved against time. Our measure of accuracy, in this case, is mean absolute error. Since this is the metric we chose in the Set Target tab as our error metric down here. To read this, the lower the mean absolute error is, the higher the accuracy. Do you see how there are various stretches of plateaus here and thus, followed by vertical drops? These drops represent moments where Eureqa was able to take evolutionary steps forward and found models that immensely improved accuracy. Here, we see quite a few of those drops and no real plateau in the progress plot yet. This echoes what we learned in the maturity measure. We could still get major improvements in the accuracy of our models by resuming the search. But again, remember, we only ran this for 20 minutes. Finally, the bottom of the tab shows the project log. This is fairly straightforward. It outputs any new solutions it's able to find, along with the details of the solutions, keeps a log of connectivity to the cloud servers if you're connected to them, and logs when the search is started, paused, or stopped. Moving on to the View Results tab, we can then view the best solutions that Eureqa was able to discover and details about those solutions. The top left corner lists the solutions that Eureqa discovered and ranked as best. For each model, it shows the number of terms used in that model, how well it fit the data, and what the equation is. Eureqa ranks these by a combination of size and fit, but you can change the ranking yourself to rank purely by size or fit. To get an overall sense of the types of models that Eureqa has discovered, see the Pareto front display in the bottom right. For each solution listed, this chart shows how they rank in terms of complexity against error. Anything that lands up in the bottom right-hand side is a model that is extremely accurate, yet extremely complex. These models have the advantage of closely fitting the data, but complex models take many more computational resources. Conversely, anything in the top left is a model that is extremely simple, but not too accurate. These models run very quickly, but your results won't be too accurate. Ideally, you'll want to choose something that falls in the happy medium in the middle. Here, we can see that there's a sharp decrease in accuracy once you get lower than 14 terms. Of the 4 most accurate models, though, there's only a 0.3% difference in accuracy, but a 20% difference in the number of terms used. If this was my final analysis, I would probably choose a model with 14 terms as the best blend of accuracy and complexity, but the trade-off that you decide to choose is up to you. Now, to see the details for each model, the top right corner shows a solution plot for each of the models. So for each model that you select in the list on the left, this solution plot graphs the actual data points against a prediction for that particular row. It's tough to read right now due to the sheer quantity of data points, but you can zoom in to look at the different data points in more detail. So let's zoom in on some random area. Say here. Again, there's still quite a lot of data points, so we can continue zooming in. But with this already, you can see that there are blue dots that signify the actual data points, and the red line that shows the model's prediction. For the most part, this model seems to be following the data extremely closely. To zoom back out, just double-click within the plot. Along the same lines, the bottom left corner shows the specific details of each model listed. Again, as you click through each model, you can see what the equation is, the R-squared goodness of fit, the mean squared error, and more. In our case, the mean squared error measures the average error of this model's prediction against the actual data. If you recall, this training set focuses on future bond prices, where the average future bond price in this data set was $105. To expect an average error of only 93 cents on future predictions is incredible. Finally, let's quickly take a look at the Report Analyze tab. You have a few different reports you can look at to understand what your search has discovered. I think a few of the most interesting ones are the Summary Report, Evaluate and Predict Analysis, and the Calculate Model Statistics. However, as you can see, there are quite a few other options you have here. So first, the Summary Report gives you an overall view of the search. It gives you a more visual way to see which variables Eureqa found to be most important to the target variable and which weren't. So in this case, it seems like the most important variables were the last price that the bond traded at and the curve-based price. If you scroll down a little bit, you can see which variables were not actually used in any of the reports, in any of the models. Now scrolling down even further, you can see the details of each solution, where you see, again, the formula, you see how it performed, you see output versus row, and another Pareto graph. Moving to the Quick Evaluate and Predict values, in this tool you can input a row of data or more where you just leave the trade price column empty. With this, once you fill out the solutions that you want to evaluate and run, it will then try to fill in the missing target variable based on the other parameters that you've given it. This is a great way to quickly evaluate the predictions that your solutions make against just a couple rows of data. Finally, the Calculate Model Statistics gives you a way to evaluate your models against an entire database of values. So right now we only have the current data set that's available to evaluate, but you can upload additional ones and evaluate how each of your predictions, each of your expressions, performs against that. There are many more tools available on this tab, which I'm not going to review now, but you should take some time to check them all out. So let's recap what we walked through today. We went through the process of predicting the next price that a corporate bond would trade at. To do this, we talked about how to import the data, your various options for preparing that data, setting up your search, and we reviewed the top models that Eureqa discovered for us. There was quite a lot that we covered in this tutorial, so feel free to just go back and rewatch any parts that you may not have fully understood, or to find anything that you may have missed. Lastly, we offer a few other services as well. While we are first and foremost a software development company, we do work with companies for pilots. These typically happen in situations where companies not only want to use our software, but also use the expertise of Newtonian's own data scientists. Additionally, we have a few other products, such as the server product I mentioned earlier, and all of our products are free to try, so I encourage you to check them out and see how they might work for you. Finally, we would love to talk with you about any OEM opportunities where you embed the power of Eureqa within your own applications. So, if you have any questions, please reach out to me. You can email me directly at jess.lin@newtonian.com. Alternatively, you can contact the rest of the team here by emailing contact@newtonian.com. Well, thanks for watching. I hope you found this video instructional and help you get started on creating your own searches with Eureqa. Have a great day.